All right, guys. Let's go over inverse trig functions 4.7. So the main idea, hoping you guys remember inverse functions from college algebra, but we want to be able to undo the sine function or all six trig functions. And in order to do so, in order to solve that x, which is usually angles, we need the inverse. So we end up defining a one-to-one function because if you see here, this function is not, what's the word? One-to-one because it keeps repeating itself. So we have to restrict it. Oh, excuse me. Excuse me. We have to restrict it in order to make it one-to-one because that was a requirement for inverse functions. Okay. Let me check here. Okay. So we end up doing is right here. See this? We restrict the sine function, and then we define the inverse sine, or sometimes called the arc sine. So here's the definition, which I'll put on paper. I'm going to post it in a minute, added more details, but basically, y is equal to sine inverse of x only if sine y is equal to x. So if and only if, that double implication arrow. Arc sine is just another notation for sine inverse. The -1 means the same thing. So whenever you see that on the sine function, we're talking about the inverse function. Okay. It's just two ways to write it. And here's a restriction. So the domain becomes this, which is the opposite. If you remember back in college algebra, we said that the domain of the regular becomes the range of the inverse, and then the range of the inverse becomes the domain of the original. And you can see that here in this graph, this one here. Anyway, using the properties and using the definition, we're going to find the angle. So remember, uh, the original trig functions, you would plug in an angle and you would get a value on the unit circle, right? You would plug in an angle, get a value. So now the inverse functions are the opposite. You're going to plug in an inverse. I'm sorry, you're going to plug in a value into the inverse and get an angle back. So let's go ahead and switch to the paper here. All right, there it goes. So real quick, I added this reminder for everybody. F inverse of f will cancel each other out. So if you have the original function inside of the inverse, it would always undo each other, kind of like square root of x and x squared. They cancel out, leaving you with x. And this is true for all x in the domain of the f function. So the one that's going inside is the one that you got to look at. So all the values defined in f, this is true. And then the opposite is true. If f inverse is inside the f, these will cancel, giving you x. But it would only be true for the values of the domain of f inverse. Okay. And here are the definitions, and I also put the domains and ranges, the ones we're talking about today. So y equals the sine inverse if and only if x is equal to sine y, that's our definition. Domain is -1 to 1. Range is -pi/2 to pi/2. So here's the cosine and the tangent. Sine and cosine are similar, but remember, the range will be different because these are based on unit circles and where we restricted them. So we restrict sine and cosine and then define the inverse like this. Tangent is also restricted and defined this way. Okay. And here are some properties that we're going to use in just a minute. So remember, Sine inverse of sine. So if I want to get that angle or solve for that x, whatever that x is, I have to do the inverse of both sides or of the outside. But it will only be defined if x is between here and here. So whenever you're trying to check, is this defined? Is this defined, etc.? You have to look at is the x within these values for these examples, for 1 through 6. I never remember this, so I just always double check or write this down. So I would put this on a formula card because the examples we're about to do, we got to figure out, okay, if I'm trying to cancel it, is it in here? Um, anyway, let's start working on the problems. Let's start with some easy ones. So cosine inverse of 0, or which is the same as saying arc cosine of 0. So at what angle is the x 0? So if you look at your inner circle, you're going to see that this is going to be pi over 2, right? So if we use the definition, cosine inverse of 0 is basically saying that cosine, there exists an angle of cosine, or in cosine, that is equal to 0. What is the theta? And our answer, when you look at the circle, is pi over 2. So just go check your circle here. Okay. Example 2. Okay. What is sine inverse of 1? So look at the circle and remember where it's defined. We're in the domain and range of sine inverse. It's defined from pi over 2 to negative pi over 2. So this is going to be pi over 2. Okay. If we use the definition, right, sine inverse of 1 is equal to pi over 2. That implies, right, double implication, back and forth. This is true if and only if sine inverse pi over 2 is equal to 1. So what is the angle? Well, the angle is pi over 2. Then you can change it back and forth. Just remember the domain and range for the inverse functions. Example 3. Again, I'm getting these numbers, this angle from the circle. Example 3. Cosine inverse of negative half. Look at your circle. That will be 2 pi over 3. This is the same thing, same. Yeah, this is the same. Thing as same, or that sounds weird. That's cosine 3 pi over 3. 2 pi over 3. Yeah. Again, this is just from the circle. If you're wondering where am I getting these answers, pause it and go to the unit circle and find out when is this 1, when is this negative half, when is cosine equal to negative half, which is the x value, the y value, and the angle where it happens. Okay. Now let's use let's do an example, kind of like a word problem, but let's start simple. Use an inverse trig function to write theta as a function of x. Tangent theta is equal to, so this is what I'm going to use because, oh, I didn't write the triangle. Let me write it down so you can see the logic. Here's theta, x over 3. They want us to write theta as a function of x. So since I have opposite and adjacent, I'm going to use that tangent. So that's why I chose this, which is equal to x over 3. So if I want to create a function of x over 3, I would have to solve for theta. If I want to write theta as a function of this, solve for it. So what you do is you tangent inverse of both sides. Which gives me theta. This cancels out. Let's isolate your theta here as tangent inverse of x over 3. So now I have a theta as a function of x. And that's all we want. So these cancel. Just imagine this as square root of an x squared. Same principle. They cancel out because they are inverses. Now let's go back to the worksheet. So we did questions like these. I did one with the theta as a function of x, which we'll get back to in a minute. But here, number 8, we'll call this is not number 8 for us, but I'm making up extra examples. Example 5 for us. Here we just have to use a calculator. There's just no way around it. I still haven't charged mine, damn it. Arc cosine of 3 over 5. Okay. So arc. So first we got to decide is 3/5 within the domain, right? Oops. Of arc cosine. And it looks like we're good. So we just round. Go back to the question. Just round to whatever they ask. Also check if it's in degrees or radians, depending what they ask for, right? I don't know if this question doesn't say, but your calculator will give you degrees or radians. So you gotta choose. Next one, sine inverse of 4.57. The same as arc cosine. Yeah. That's all you got to do. Same thing for tangent. Just check and see, okay, am I good? So we don't need to do that on paper. You're just plugging in your calculator and seeing if you can find it or if it's undefined. Sometimes if it's not a number or if it is a number and it's obvious, just say undefined. If you remember the domain and range. Or you can plug it in and see what happens. So I'm going to go ahead and call this example 5 because 8, 9, and 10 don't really need to be written down. It's just a calculated question. 11 has some paperwork and then calculator. This is use a calculator to approximate the degree measure to 1 decimal place. Of the angle of theta, where sine theta is equal to 3/8. And theta is between 90 degrees and 180. So whenever they say this, 90 degrees less than theta less than 180, they're saying the angle of theta is between 90 and 180, which is quadrant 2, right? If you look at your circle, it's 90 degrees at the top, 180 is over here, so between here, quadrant 2. Okay, so I'm going to shift back to the paper. Here are the formulas I wrote down at the beginning, by the way. We're going to use that for the next set of questions. So basically, they want us to solve for theta. So in order to do so, take the sine inverse of both sides, assuming that this 3/8 is in the domain. And if it isn't, you'll find it right away. So these cancel, and then I need my calculator for this. Let me find out on decimals. Inverse sine or arc sine of 3/8 is roughly 0.384. Let me see if I'm in degrees or not. I'm in radian, so that's radian. Degrees would be roughly 22.024 degrees. Okay. Now let's look at these here. Remember we said sine inverse on the outside, so look at this right here. If the inverse is not the second one, sine inverse of sine, the x in question has to be between negative pi over 2 and pi over 2. Negative pi over 6 is good, so it should be fine. So this one's defined. The output would be, let's see, let's go to Desmos. He was smart enough to do this one. Oops. Need parentheses. Negative 0.5. Am I in degrees? Okay, so that's my radians, which is the same as what? Pi over 6, right? Yeah. So this is basically these two canceling. So we go back to our, right? Go back to here. We said that this would just cancel, leaving us with negative pi over 6. I don't know why I'm writing all weird. This one again is this within the domain. 7 pi 6, I think it's kind of large. Where is that? Let's put up the circle. This is the one I sent you, I think. 7 pi 6 is way over here, so it would be outside the range. So you would have to, it would be undefined technically. 7 pi 6. So let's go to the homework and find something similar, just so you can see one of yours. Yeah, let's check it out. So this will cancel out, right? The tan to arctan cancel, giving us just the square root of 3. They undo each other. Just like the note said, just like the last example. Trying to find one that's complicated. Maybe this one. Yeah, check this one out. So this one is outside the domain. So yeah, you technically would get an error if you try to do this all. Oops, actually this is tan and sine. We're gonna do that next. Yeah, we'll come back to this. Back to the notes. Yeah, so these will all cancel unless they're too big. So just put undefined, or you'd have to find a similar angle. Cosine inverse, the cosine inverse is on the outside. Has to be between 0 and pi. Well, negative half is not between there. So b and these two b's are undefined. 13, cosine inverse of cosine. 7 pi 6 again is too large, so that these three would be too large. Now let's do one of these type. Example 6, let me go ahead and write this one out. And if they say find the exact value, you're going to have to use triangles to kind of deal with this. Your calculators won't do it. So part A, cosine of sine inverse of 40 over 41. So what you do is say let your theta equal sine inverse of 40 over 41. Say there's a theta that gives me this. Use the definition. That also means that sine of theta is equal to 40 over 41. So once you do this, you can build your triangle. So by definition, this is implied. I can't find the cosine. Basically, the question, let's get back to the beginning. What they're asking for is the cosine given this information. But I can't do anything with this at the moment. So what you can do is remember the definition of sine inverse, apply it, and then build your triangle. We know this is equal to opposite over hypotenuse. So solve for this missing side, right? We know that x squared plus y squared, or we usually use a and b, sorry. We know that a squared plus b squared is equal to c squared. So that's going to be a squared plus 40 equal to 41 squared. So that means that a squared is equal to this stuff. Which means that a square root both sides, right? Is equal to whatever this is. Don't know what that is. Let me get my Desmos here. Square root 41 squared minus 40 squared. So it looks like it's going to be 9. Cool. All right. So now we can answer the question, right? Cosine of theta is going to be adjacent over hypotenuse. So you can answer this guy up here now. This will be 9 over 41, right there. Okay. The part B, let's do this is part B anyway. It's the same thing, but cosine of sine inverse of negative 40 over 41. That means that there exists a theta that's equal to sine inverse, just defining it myself, which implies that sine of some angle, theta, has to equal negative 40 over 41. Now, they didn't tell us which quadrant this is in. They only told us that sine is negatives, but so cosine of theta has to be, I can't find it until I build the triangle. But we already know what it is, right? it has to be uh, opposite hypotenuse. Cosine has to be well, since they didn't say if it's negative or not, can't really use it. But let's make sure of something. Is negative 40 over 41 in the domain for B? If you look at our notes or the formulas in the notes, we said that if it's sine inverse is defined negative 1 to 1. Yeah, it's less than 1. Okay, now we're good. We're fine. So since they didn't tell us where theta is, we can't say anything about 9 or the adjacent sides. Okay, let's go back to this next problem. Example 7, write an equivalent expression for, so we're doing the same thing as we just did, but now it's algebraic terms. That is equivalent to cosine of arcsine of 3x. So build your triangle in general. So here's the triangle I need to build. Let theta equal to arc sine of 3x, which implies that sine of theta is equal to 3x. Or you can think of it as doing sine of both sides, but I just apply that definition nowadays. So opposite, adjacent, solving for this side would be this, right? So this adjacent side is 1 minus 9x squared. So just like we did before, find the missing side. They're just algebraic terms instead, and then find the cosine. So now cosine of this theta has to be the adjacent over hypotenuse, which is just this. So that's what they want here. So whenever you get something that's not mismatching, like cosine and sine inverse, and then it's algebraic or a number like we did before up here, right? We got a number. We built the triangle, found the cosine. We built the triangle, we found the cosine. That's all you got to do. Okay. I think we have time. We should do one more maybe. Yeah, we'll do this one. Number 15 in the notes. Right tangent of arc sine of 2 over x as an algebraic expression. So the same deal, right? Like theta equal arc sine of x over 2. You could think of it this time as sine of both sides for no reason. Ah, shoot. So sine is equal to x over 2. Build your triangle. Opposite over hypotenuse. Find the missing side. That'll be square root of 2 squared minus x squared. 4 minus x squared. So tangent of that theta will equal opposite over adjacent. So x over the square root of 4 minus x squared. This is the opposite. So, Jason, sorry. All right, now we'll stop there.